Hi class, this is Mr. Morris again. We're going to continue talking about the ideal gas law, moving on to those questions that involve density. So if you look at these notes, we've got this section right here we mentioned in the last video. It says the ideal gas law can be rearranged and combined with the formula of density and the definition of molar mass. So density is mass over volume. Molar mass is mass over moles. And we could go through the whole derivation of this, but when you combine those together with the ideal gas law and eliminate the variables that get canceled out, you end up with this formula. Easiest thing probably is just to memorize molar mass equals dRT over P. It almost sounds like dirt over P. Molar mass equals dirt over P. We're only going to do that if we are dealing with density. If density is not involved in the question, it's just not really worth using this equation. It's a lot easier to use PV equals nRT unless density is involved. So let's go ahead and move down to one of those problems that involves density. We're going to look at number 3. So number 3, it says, what is the molar mass? Pure gas that has a density of 1.40 grams per liter. So we've got density here. That's where we know that we're going to use dirt over P. And it says at STP. Don't forget STP, that's standard temperature. Instead of doing PV equals nRT, we're doing molar mass equals dirt over P. So molar mass D R. It's an equal sign. It doesn't look like it. And then we have P and P. Right. It asks for the molar mass. R 0.0821 liter atmospheres per mole Kelvin. 3 Kelvin. Pressure is 1 atmosphere. And actually, to keep our sig figs consistent, we should put 1.00 atmospheres. And get my eraser real quick, and I'll fix that. Zero atmospheres. Okay. It also says afterward it wants us to identify. So our part 2 here is going to be to identify the gas. The gas is diatomic. So don't forget, we've got to remember the gas is diatomic, and we want to know what it is. But first, let's answer the first part of the question, which is, what's the molar mass? Molar mass equals dirt over P. Density is 1.40. 0.0821. T is 273 over P, 1.00 atmospheres. So really, we're just going to multiply this and this and this and divide by 1. So we end up with 30. Well, there's my pen. 31.4 grams per mole. So at this point, what we want to do is move on to the next part of the question. It asks us what the identity of the gas is, considering that it's diatomic. I'm switching colors to keep as we go through this. So diatomic means that whatever it is, so let's just say that it's X. We're going to call our element X. X2 has a molar mass of 31.4. So 2 times the mass equals 31.4. Really what we're saying, 2x. So I need to do 31.4 divided by 2. 31.2 over 4. or 31.4 over 2, sorry. And you get 15.7. Want to look at a periodic table for that. You're not going to find an element that has exactly a mass of 15.7 grams per mole, but you do see oxygen, which has 15.999 grams per mole. It's as close as you get. So this is oxygen, our element. The identity of the element is O2. That's our final answer. All right. The other questions are going to be some variation of those two. So it's either going to be using PV equals nRT or using the formula we just talked about to find density or to use density. So if density is involved, use this one. If not, use PV equals nRT. Don't forget, always convert your values to be pressures of atmospheres, volumes liters. N will be moles, T is K, Kelvin. You can go between moles and grams. Just check carefully to make sure you're answering the questions that in the way that it asks. We're going to call that good for this video. Probably make another one where I work through the example problems. That'll be totally optional. You can work those on your own if